Hello everyone, my name is Abhishek and welcome back to my channel. So today we are at day 36 of our complete DevOps course, and in this class we'll be talking about Kubernetes interview questions part 1. Now what is this and why I have decided to do this video? Because ideally today's class has to be on the practical services implementation and introduction to Ingress, but why I have decided to do this interview questions is, we have been learning about Kubernetes from past 5 to 6 days, and we have covered a lot of topics like Kubernetes architecture, comparison with Docker, deployments, pods, containers versus pods. So we have covered some very interesting topics, and these are the topics that interviewers will ask you, during your course of interview. So I thought to check how much concept have you grabbed, or how much have you understood from the past videos. So this is a really good exercise that we are going to do today. You can consider it as a mock interview, you can consider it as anything, but what you will do is try to answer the questions. Like whenever I show you the question number 1, okay, firstly I'll not show you the answer, I'll just show you the question. So try to see how many are you able to answer before I reveal the answer, okay, so that you can give or you can assess your score by yourself. So if you want, you can also comment your score below. So there is no competition kind of a thing here, but the only thing is you will understand how others are, taking the topics, or are they practicing the topics so that they are remembering the concepts, so that you can consider it as a feedback or retrospective for yourself. Okay, so without wasting any time, let us quickly jump onto the video. I will have 10 questions for you. I have 10 questions for you, and let us see how many of you can answer how many number of questions. So, firstly, the question number 1. Sorry for that, lines. I can quickly remove them. No worries there. So just clear the drawings here. Perfect. So the question number 1 is, what is the difference between Docker and Kubernetes? So today's questions will be scenario based questions, and so here what you need to do is try to answer this question by yourself. Okay, pause the video here and try to see if you can answer this question. Assume you are in an interview, and see if you can answer the difference between Docker and Kubernetes. Okay, so the answer for this would be, I have also explained this in the previous video. I think the very first class when I have introduced you people to Kubernetes, in that class itself I told you that Docker is a container platform and Kubernetes is a container orchestration platform. I also have answers for you, don't worry. So Kubernetes is a container orchestration platform, and what Kubernetes adds to the Docker is, containers are ephemeral in nature. That means to say, a containers can go down, containers, for multiple reasons. If a container goes down, then your application is already down. So your end user who is trying to access your application, he will see a traffic loss. So to avoid that, you can move to a container orchestration platform solutions like Kubernetes, which will offer you auto healing, auto scaling, which will offer you, because Kubernetes is a cluster itself. Like in production, you can join or combine multiple virtual machines and create a Kubernetes cluster, so that even if one of your nodes, let's say Docker is a single node platform, right? You install Docker on a platform and you start your container. If that node itself goes down, for example, your laptop has gone down for some reason, so your application is not reachable. But what Kubernetes offers is, if one of the node goes down, because it's a cluster, it will immediately move the pod from that specific node to a different node. And finally, it also has many enterprise capabilities like load balancing. It can offer integration with custom resource definitions, or you can deploy any custom Kubernetes clusters, controllers that are developed by other people, like for example ingress controllers, right? So there are multiple ingress controllers which can offer you advanced capabilities. So in nutshell, you can extend the capabilities of Kubernetes cluster using the custom resources as well. So this is the primary difference between Docker and Kubernetes. Let's say you have not understood this one because you are watching this video, even before watching the previous videos. Then I'll highly recommend you to watch our video, I think day 31, where I explained and compared the difference between Docker and Kubernetes. So it was complete 30 minutes class where we took plenty enough time to understand the comparison between Docker and Kubernetes. So now, if you are able to answer this question, assuming that you are in an interview, then yeah, you get 1 mark here. Okay. So Question number 2, what are the main components of Kubernetes architecture? So this is one of the most asked interview questions. Okay, so you go to an any Kubernetes interview, the interviewer will definitely ask you this question because Kubernetes has a lot of components. And when I explained you in day number 33, I guess, the architecture of Kubernetes, that is what I actually, like, I took 40 minutes of time to explain about the Kubernetes architecture because it's a very important topic. Whenever you plan to learn about Kubernetes, you should understand how how multiple components of Kubernetes are talking to each other and how the Kubernetes is maintaining its robustness. So in a nutshell, when somebody asks you this question, what you need to say is, on a very high level, I can divide Kubernetes into control plane and the data plane. On the control plane, you have components like API server, which is responsible for handling the APIs, talking to the end users. And then you have the scheduler, which is responsible for scheduling the resources on the Kubernetes cluster. Then you have etcd. Etcd is a Kubernetes object store where all the resources of the Kubernetes are stored as objects in Kubernetes. And then you have controller manager. So controller manager is basically, uh, for example, you have a replica set or replication controller. So controller manager is something that takes care of these default controllers in Kubernetes. And then you have cloud control manager. So cloud control manager is, in the last class I explained you, let's say you want to implement the Kubernetes on any cloud provider. For example, Amazon has implemented Kubernetes as managed service on EKS platform. So whenever you install this Kubernetes cluster, what these cloud providers will do, they will contribute to the cloud control manager, and they will say, like, let's say you created a service of type load balancer. So what happens under the hood is the cloud control manager has the logic that is written by the people at AWS, which can spin up a load balancer IP address for you. Okay, so when you create a load balancer service type, you are getting a load balancer IP address on the AWS, but who is generating this, right? So cloud control manager is doing this with the help of the contributions from the people of AWS. Tomorrow, if I write my own cloud, then what happens is I have to go ahead and contribute to cloud control manager so that uh, Kubernetes can, like, let's say somebody creates a service on my cloud, then the cloud control manager can act and give you a load balancer IP address. So this is about the control plane or the master node components of Kubernetes. And then you have the data plane where you have three primary components. One is kubelet, one is kube-proxy, and then the final one is container runtime. So people also say there is one more component called DNS, but you can restrict yourself to here where you can talk about kubelet, kube-proxy, and container runtime. So kubelet, you all know, it is responsible for managing the pods. Let's say if pod is running in a healthy state or not. A pod has to be restarted. If the pod has gone down, then kubelet takes care of starting the pod. So kubelet is a component that is responsible for managing the pods on the nodes. Then you have kube-proxy. Kube-proxy is a networking component of Kubernetes, which typically takes care of updating the IP tables. For example, you create a service of type NodePort. So what under the hood happens is the kube-proxy is the one that understands that, okay, there is a service that is created of type NodePort. So I have to go ahead and update the IP tables in such a way that somebody access the node IP address colon a specific port, the request has to be sent to the pod. Okay, so kube-proxy is the one that takes care of the networking. Finally, you have container runtime. What is container runtime? So container runtime is nothing but, for a container to run, you need a runtime. For example, if you have a Java application, and for Java application to run, you have a Java runtime. Similarly, for containers to run, you have container runtime. And Kubernetes is not opinionated about this one. Like, you can use Docker shim, you can use containerd, you can use creo. Previously Kubernetes was opinionated because it only used to support Docker shim out of the box. Okay, but now out of the box nothing is supported. You have to install the container runtime on each and every node. Okay, then So here interviewer might ask you one question. I've seen sometimes, like when you say Kubernetes is not using Docker shim out of the box, or Kubernetes is not using Docker as runtime out of the box, does that mean Kubernetes is not supporting Docker? No, it supports Docker, it supports Docker shim, but nothing is available out of the box. Let's say previously when you install a Kubernetes cluster, on each worker node you used to get Docker shim runtime out of the box, but now it's up to you. Like you can install Docker shim, you can install containerd, you can install Creo, any container runtime that implements the Kubernetes container runtime interface. Okay, let's not go into the details of it, but if you want to understand the details, you can watch my Kubernetes architecture video. That should be day 32 or 33. Then what are the main differences between Docker Swarm and Kubernetes? So this I haven't covered in my previous videos, but many people are asking about it in the comment section. So Docker Swarm and Kubernetes, what is the difference? Why we have to use Kubernetes when we have to use Docker Swarm? So basically, if you look at the popularity, Kubernetes is quite popular even when you compare against any container orchestration environments, whether it can be Cloud Foundry, it can be MesoS, Marathon, Docker Swarm. So Kubernetes is a quite popular choice. And if you talk about Docker Swarm is a Docker-based solution, right? So the major difference is Kubernetes is suited for the enterprise, like large organizations or even mid-scaled organizations, whereas Docker Swarm is very easy to install, it is very easy to use, but it is only suitable for the small scale or very simple applications. The reason for that is, when you are going for scaling, Kubernetes has multiple options, and when you are going for advanced networking capabilities, Kubernetes can do advanced networking capabilities very easily. Like you can use Flannel, Calico, or SDN, OVN. So all of these things with Kubernetes very easily, and with Docker Swarm the support is very limited. And the other important thing is that you have a lot of third-party support for Kubernetes. Like for example, the CNCF community, it has been very active, and because Kubernetes supports something called as custom resource definitions, so anybody who can write a Kubernetes controller, if they feel that Kubernetes is not supporting something, they can extend the capabilities of Kubernetes, right? Because it's all about installing and deploying a controller in Kubernetes, and you can extend the capabilities to whatever extent that you want. So this is a comparison on a very high level. So if you are looking for a mid-scale or large scale solution, then go for Kubernetes. But if you don't bother about the scale, then you can choose Docker Swarm, because Docker Swarm is also very easy and very simple to install and use. But you know if you look at the market today, Kubernetes has large openings, and if you even take 10 JDs, out of 10 JDs, 10 JDs in DevOps will have Kubernetes. So why should you go for Docker Swarm if you are learning about Kubernetes, or if you are learning about container orchestration environments? Then what is the difference between Docker container and a Kubernetes pod? So again, I took almost 30 minutes to explain this difference in one of the videos. So if you are trying to answer this question, you should definitely answer, and let us see how many people will get this answers correct. So sometimes what happens is, you people can answer the questions, but you people will not be able to phrase the answers. Okay, so whenever the interviewer is asking, so if you take a lot of time thinking about the answer, then interviewer might feel that, okay, so probably he does not know the answer, or he is searching for the answer somewhere, because these days interviews are also not face to face, right? So interviewer might feel that you don't know the answer. So these are some of the standard questions that you can expect in any interview. So try to be ready with the answers for these questions. Okay, so what is the difference between Docker container and a Kubernetes pod? So as I explained, a Kubernetes pod is nothing but a runtime specification, or uh, what you do is, in a YAML file, Kubernetes resources are basically written in YAML files. Okay, so in a YAML file, you can put together all of the things that are required for your container to run. So that itself is a pod. But the only difference is, in a pod, like pod is the lowest level deployment in Kubernetes. In a pod, you can create one single container or multiple containers. So if you have multiple containers, then both of them can talk within the pod using the same network. Okay, and they can also use the same storage, or same resources inside the pod. So that's the only difference between a pod and a container. So you can simply say pod is nothing but a runtime specification of a container. What is a namespace in Kubernetes? So again, many people were asking this question in the comment section. Explain about the namespace. Namespace is a very simple concept. Okay, so namespace is nothing but a Kubernetes cluster is used by multiple people in your organization, right? So there are multiple projects and multiple projects. For each project, you cannot create a Kubernetes cluster in production, because end of the day, let's say you have 20 projects which are working on 20 microservices. All of these 20 microservices together might create your end application. If you take about Amazon.com, for Amazon there can be 20 different teams working on 20 different microservices, but end of the day, for Amazon.com to function, what is required? All these 20 microservices should talk to each other and should form a single application. Okay, it will be bundled probably as different applications, but all of them are deployed in one single Kubernetes cluster end of the day. So a Kubernetes cluster, I mean, in a Kubernetes cluster, namespace is nothing but a logical isolation of resources, networks, RBAC, and everything that you can do. For example, there are two projects, and two projects you want to deploy on a Kubernetes cluster. So you will say for project A, you will create a namespace called namespace A. For project B, you will create namespace called namespace B. And within project A, there can be 10 developers. They can work on namespace A, and the other 10 developers in project B, they can work in namespace B. So what happens is you have provided them the same Kubernetes cluster, but you have created two different namespaces for them. So in that way, they have a logical separation. Physically, they are in the same Kubernetes cluster, but logically they are separated with concepts like RBAC. What is RBAC? Authentication. Then they have different network policies. They have, isolation of resources. Like in namespace A, let's say there is a deployment. In namespace B, there is another deployment. Okay, so here there is application A and here there is application B. So developers of namespace A, you can restrict from accessing the application's resources in the namespace B. So this is how your namespace isolation works. Okay, so to separate the isolation, or to create the isolation, to form this concept, what you can do is you can make use of the RBACs. Okay, RBAC is nothing but role based access control. So we'll talk about the RBAC. For people who don't know about RBAC, don't worry about it. But for now, if somebody is asking you what is a namespace, you can simply tell a Kubernetes namespace is a logical isolation of resources, so that multiple project teams in a company can work on the same Kubernetes cluster, but each of them will have a dedicated namespace, so that nobody will interrupt the work of the other people or other projects. What is the role of kube-proxy? So this is question number 6 till question number 5. uh, let us see how many people were able to answer all the 5 questions till question number 5, because more 4 questions I think we covered already in our previous classes. Let's see. Now question number 6, what is the role of kube-proxy? So again, this I explained in one of the previous classes. So kube-proxy, I think I explained even during the question number 2, where we discussed about the architecture of Kubernetes. But if somebody asks you dedicatedly, like, please elaborate more on the kube-proxy, so I've written some description here. You can write down this description somewhere, or you can, as it easily, you can copy paste the description when somebody is asking you. Kube-proxy basically is about configuring the network rules, okay, on each of the node. That means to say, like the fundamental example that I gave you, if a user creates a service of NodePort mode, okay, so that means to say your pod can be accessed on that specific node IP colon the port that you configured in your service.yaml file, right? But who is doing these things under the hood, right? So who is saying that when somebody sends a request on the node IP followed by the port number, the request has to be routed to the pod. Okay, somebody has to say this configuration, right? So kube-proxy is the one. What it does is, on every Linux machine, there is a concept called IP tables. Okay, so kube-proxy, I mean, you can configure kube-proxy in different modes, but by default one is kube-proxy updates the IP tables. So whenever somebody access the application using, let's say your service is on NodePort mode, so if they access the URL, or if they hit the URL NodePort colon port number, the kube-proxy, because it has configured the IP tables, the request is sent from that specific node port colon, sorry, node IP colon port to the pod. Okay, so this entire routing is done using the kernel and the IP tables. So you can also use IPVS and other things, but by default mode is IP tables in Kubernetes. Okay, so this is about kube-proxy, and I've also provided the description here, so that if you want, you can copy this description and you can say it as it is. Okay, when you want to convey it to your interviewer. Then what is the different type, sorry, what are the different types of services within Kubernetes? So day number 36, sorry, 35, when we talked about services, I explained three different services in Kubernetes. So this is the question again, where if somebody asks you what are the different types of services within Kubernetes, so fundamentally I explained you services has three major responsibilities, right? One is load balancing, one is the service discovery, and finally to expose your applications to the external world. These are the three major responsibilities of a service in Kubernetes. So service discovery, load balancing, and exposing the applications. So service discovery and load balancing I already explained. Now this question is about how to expose this application outside the Kubernetes cluster, or what is the networking that you have configured, or what are the different types of services that are available in Kubernetes, service modes that are available in Kubernetes. So the answer to the question is you can create three different types of services in Kubernetes. One is you can configure the service mode as cluster IP mode. Second is you can configure the service mode as NodePort mode, and the third is you can configure the service mode as load balancer mode. So this is a straightforward answer, but your interviewer will definitely, ask you to elaborate more. Can you elaborate the difference between cluster mode, node port mode, and the load balancer mode? So in the last class, I explained difference between each of them. In tomorrow's class, you will see the practicals as well. But again, if I have to explain you, the cluster IP mode, what happens if you create a service as a cluster IP mode? So your pods, or your service will basically get a cluster IP. So if you try to access your service, so you will be only able to access the service using the cluster IP, which is only available or accessible within the Kubernetes cluster. Okay, whereas if you try to create the service as type node port mode, then your service can be accessed on the node IP colon the port number that you define in your service.yaml file. So what happens with that? Anybody in your organization who has the access to your node IP address. For example, you have created a Kubernetes cluster on your AWS platform. Okay, so what happens is you have configured your worker nodes as EC2 instances. So now anybody who can basically reach that EC2 instance. So if you can just ping the IP address of the EC2 instance, then that means to say that your node is accessible to that specific users. So whoever can access the nodes, whoever can access the worker nodes, or whoever can access the IP address of your Kubernetes cluster, then they can basically access your applications if they are deployed in the node port mode. But for the end users who are sitting outside your organization, okay, so your end user is somewhere in India and your applications or your Kubernetes cluster is somewhere in the US. So in such cases, if they don't have access to your network, and if they are outside your organization, then you have to expose your applications as load balancer mode. Okay, so what happens if you do that? Your cloud control manager component of Kubernetes, basically it will create a public IP address for you, or it will create a load balancer IP address for you, and using which you can, anybody in the world can access that applications. Okay, so this can also be done using ingress, but the question is only related to services, so let us restrict to service only. So again, the question is same here. What is the difference between NodePort and load balancer type service? Because this is a very frequently asked question. I thought I'll also put this question here. So the description is same, the one that I just explained. So you can pause the video here and you can read the description. Question number 1. What is the role of kubelet? Okay. So here, when I explained you about the architecture of Kubernetes, so I told you that kubelet is a very important component, right? Because kubelet is very, kubelet is the one that is responsible for managing your pod lifecycle on the worker nodes. So whenever you install or whenever you schedule a pod on the worker node using the kube scheduler, so the pod can go down for some reason, or a pod can something can happen to your pod. So there has to be someone who has to inform the kube API server that okay, the pod has gone down now. You have to send the information to the replica set or the deployment, and it has to scale up the pod. Okay, so if your pod count has to be 1, so if for some reason the pod has gone down and the replica has become 0, so your replica set controller has to know that okay, the pod has gone down, so I have to ensure that the pod comes up and I have to scale up the pod. So this information is actually continuously monitored by the kubelet. So kubelet always watches that pod. If it goes down, then it sends the notification to the API server, and then API server notifies the replica set controller, and then you know the replica set controller again spins up, or it increases the scale to the required amount. So this is the life cycle. So on a high level, what pod is doing, so pod is the one that is responsible for managing the kubelet is the one that is responsible for managing the pods on the worker nodes. So I've provided the description as well, so that you can explain the answer to your interviewer during the interviews. Question number 10, and this is a very important question: what are your day-to-day activities on Kubernetes? So many people get confused here, and I see also many people asking that Abhishek, I'm getting the theory knowledge, I'm able to practice using your videos. We were able to get some understanding of Kubernetes and the DevOps itself. But when somebody asks us the question, what are the day-to-day activities as a DevOps engineer, or what are the day-to-day activities on Kubernetes, we are not able to answer. So don't worry about it. Actually, it's a very easy question, or it's a very simple question to answer. And if you are starting with a good answer, like this will be your first question. Interviewer can ask you, what are your day-to-day activities on DevOps, or what are the day-to-day activities on Kubernetes? So because this is your first question, or most probably in first 1 or 2 questions, if you answer this question in a very good way, then it boosts your confidence. And this question is a very simple one. You don't have to complicate the question or complicate your answer. Simply say them that as part of the DevOps engineer role, we manage Kubernetes clusters for our organization, and we also ensure that the applications are deployed onto the Kubernetes cluster, and there are no issues with the application. So we have set up monitoring on our Kubernetes cluster. We ensure that whenever there are bugs on the Kubernetes cluster, for example, the developers are not able to troubleshoot some issue with respect to pods. Developers are not able to troubleshoot with respect to services. They are not able to, route the traffic inside the Kubernetes cluster. So in such cases, as subject matter expertise on the Kubernetes clusters, we come into picture and we solve their problems. But apart from that, we also do a lot of maintenance activities. For example, we have Kubernetes clusters with 3 master nodes and 10 worker nodes. So we have to do some continuous maintenance activities on these worker nodes, probably upgrading the versions of these worker nodes, or installing some default mandatory packages, ensuring that these worker nodes are not exposed to security vulnerabilities. So all of these things are our day-to-day activities on Kubernetes. Apart from that, we also serve as subject matter expertise on Kubernetes. So if anyone in the organization has any issues with Kubernetes, they create a Jira items for us, or they create tickets for us, and we will help them in solving, or making them understand the concept of Kubernetes. So this is how you can explain. So it's a very simple answer. It's a very straightforward answer. You don't have to get scared about this question. So these are the 10 questions that I have for today, and let us see how many people were able to get all the 10 questions correct, because most of the questions we have covered. I think 8 questions we already covered in the previous videos. So let us see what is the scorecard. And yeah, in future videos we will learn about ingress. We will learn about the practical implementation of services. We'll also talk about custom resource definitions. We will see a few things about Helm. So it's going to be 4 or 5 videos more on Kubernetes, and after that we'll also do Kubernetes interview questions part 2. So if you like the video, click on the like button, and if you feel that someone who is not following our 45 days of DevOps course, please share these videos with them, so that they'll also get benefit out of the videos. Thank you so much. I'll see you in the next video. Take care, everyone. Bye.